Hey everyone and welcome. Today we're going to pull back the curtain on something we all do pretty much every single day. Video streaming. We're going to demystify the networking magic that makes it all possible.
I mean, seriously, stop and think about that for a second. You hit play, and this gigantic file from a server that could be thousands of miles away just shows up on your screen, almost instantly. How on earth does that actually work? Okay, let's get into it.
So to wrap our heads around this, we're going to use a simple analogy for the whole explainer. Just imagine the internet is this massive worldwide postal service. Your video, it's not one big box. Nope. It gets chopped up into thousands of tiny little envelopes we call packets. And networking is just the system that makes sure all those tiny envelopes get from the sender to you.
Now, any good postal service needs delivery trucks, right? Well, in the internet world, we've basically got two main types, and they represent this really fundamental choice. Do you want it delivered fast, or do you want it delivered perfectly?
First up is TCP. Think of TCP as the certified signature-required delivery truck. It is all about reliability. Its number one job is to make absolutely sure every single packet gets there, that they're all in the right order, and that there are zero errors. It is meticulous.
So how does TCP pull this off? Well, before it sends anything, it does this thing called a three-way handshake to make sure the connection is solid. Then it numbers every single packet. If one goes missing, it literally stops everything and asks for it to be sent again. Now this creates a really big problem for video called head-of-line blocking. Imagine a conveyor belt. If package number 5 falls off, the entire belt stops, right? Even if packages 6, 7, and 8 are right there, ready to go. Everything waits for number 5. That is exactly why your video buffers.
On the complete other end of the spectrum, we've got UDP. This is the express courier who just kind of throws the packages at your front door and speeds away. It's all about speed. It's what we call a fire and forget system. It just sends the data and never looks back to check if it all got there.
Yeah, so UDP just sends. There's no handshake, no numbering, no asking for lost packets. This makes it incredibly fast, which is absolutely perfect for things like live sports or a video call. You know, you'd much rather have a tiny split-second glitch, that's a lost packet, than have the whole stream freeze up while it waits for a perfect delivery. A little imperfection is way better than a long pause.
And here it is, the whole trade-off in a nutshell. TCP gives you that high reliability, but it's slower, which is great for video on demand where you can load a bit up front. UDP is way faster with almost no overhead, making it the go-to for live events and gaming where every single millisecond is critical.
So this leads to a classic dilemma, right? For years, developers were stuck. You either picked the slow, steady truck or the fast, reckless one. But what if you didn't have to choose? What if you could have both? And that's where QUIC comes in. This is the modern solution, the game changer. It's actually built on top of speedy UDP, but it adds its own reliability features, like re-requesting lost packets. And crucially, it completely solves that head-of-line blocking problem. If one packet gets lost, the others can keep on flowing. It is truly the best of both worlds.
Okay, so we have our delivery trucks, but how do they know where to go or what they're supposed to do when they get there? Well, they have to follow the rules of the road. And on the internet, those rules are basically a language called HTTP. Let's take a look at how that's evolved.
So HTTP has really grown up over the years. The classic version, 1.1, could only handle one request at a time. Think of it like a single-lane country road. Then came HTTP/2, which introduced something called multiplexing, which is like turning that road into a multi-lane highway. You could have multiple requests going at once on the same connection. But it was still built on TCP, so one little accident, a lost packet, could still jam up all the lanes. And that brings us to HTTP/3, which just ditches TCP altogether and runs on that superior QUIC protocol. It's just so much faster and more resilient.
You've also definitely seen HTTPS everywhere you go online. That little S at the end, it just stands for secure. It's the exact same language, but it's wrapped in a layer of digital armor to protect your data from anyone trying to listen in. And that security is handled by something called TLS or SSL.
So before a single piece of your data is sent securely, your browser and the server do this super quick 4-step handshake. It's like this. Your browser says hello. The server says hello back and shows its ID card, its certificate. Your browser checks to make sure that ID is legit. And if it is, they secretly agree on a secret code, a key, to scramble everything they say to each other from then on. And this whole thing happens in milliseconds, every time you visit a secure site.
Now, it doesn't matter how great your postal service is.
Sometimes envelopes just get lost in the mail. In networking, we call this packet loss, and it's a constant challenge that we have to figure out how to deal with.
To put it simply, packet loss is just when some of those little data envelopes you asked for, they just never show up. This can happen because of a traffic jam on the internet. We call that network congestion, or maybe a faulty piece of equipment somewhere along the route.
So how can you tell if you're losing packets? Well, one really simple tool is called ping. If you're okay using a command line, you can just type ping and then a server address like google.com. It just sends out a few tiny test packets and then tells you how long it took for them to come back and if any of them went missing. It's kind of like a quick little health check for your connection.
Now, if ping shows there's a problem, the next step is a more advanced tool called traceroute. This command is like a GPS for your data packets. It maps out every single stop, or hop, they make on the journey from the server to your computer. If you see a big delay or a bunch of errors at one particular stop, congratulations, you've just found the location of the traffic jam on the internet.
But what if you can't fix the network problem? For live streams, we use this really clever trick called forward error correction. The server basically sends a little bit of extra redundant data along with the main video. Then, if a packet gets lost, your video player can use that extra data to mathematically rebuild the missing one right on the spot without ever having to pause the video and ask for it again. It's pretty cool stuff.
So, we've covered the trucks, the rules of the road, and what to do when things go wrong. Now, let's bring it all home and see how this stuff comes together in the actual streaming protocols that power the services you use every day, like YouTube, Netflix, and Twitch.
This table right here, this is where it all clicks into place. You can see how protocols like HLS and Dash, the ones used by Netflix and YouTube for on-demand video, they rely on that slow but reliable TCP. That's fine when a little buffering is okay, but then you look down at something like WebRTC for real-time video calls. It uses the super fast UDP to get latency down below half a second. And that's the key takeaway. The choice of transport protocol, TCP or UDP, is what defines what a streaming protocol is good for.
So, at the end of the day, what does this all mean? Well, now you know that the internet is basically a giant postal service. TCP is your reliable truck, and UDP is your fast one. QUIC and HTTP3 are the future, giving us the best of both. That little lock icon in your browser comes from the TLS/SSL handshake. And all those different streaming protocols out there, they're just specialized couriers, picking the right truck for the right job. So the next time you're on a flawless video call or you're watching a 4K movie without a single hiccup, you'll know about the incredible chain of networking that's happening behind the scenes. And as new tech like QUIC makes this system even faster and more reliable, it really makes you wonder, what new kinds of instant global communication are we going to see next? Thanks so much for watching.